Somewhere a million miles from Earth, at a spot called the Second Lagrange Point, a telescope with a mirror the size of a tennis court is quietly rewriting the textbooks. Not once, not twice. It's doing it right now, in 2026, faster than astronomers can keep up. In the next 10 minutes, we're going to cover 5 discoveries from James Webb that are genuinely shaking up astronomy, a hidden planet inside one of the most famous star systems ever studied, an impossible pileup of galaxies from the dawn of the universe, a mystery about Saturn that just got solved after decades, and a signal from a nearby ocean world that might be a hint of life. Let's get into it. Let's start close to home, cosmically speaking, the Beta Pictoris system. If you've followed exoplanet news for more than a few years, you already know this name. Beta Pictoris is basically astronomy's favorite baby solar system. It's young, it's bright, and it's surrounded by a huge disk of dust and gas, the raw material planets are made from. Astronomers already knew about 2 giant planets there, Beta Pictoris B and C. But this year, Webb found a third one hiding inside that dust disk, now called Beta Pictoris D. And here's the interesting part. They didn't spot it just by seeing a dot of light. They found it by detecting the chemical fingerprint of its atmosphere, carbon monoxide, water vapor, and methane, bleeding through the glow of the dust around it. That's a big deal for 2 reasons. First, it means there was a planet-sized object essentially hiding in one of the most photographed star systems in the sky, in a disk astronomers have been staring at for over a decade. Second, it's a preview of a whole new method for finding planets that would otherwise be invisible, using atmospheric chemistry as a detection tool, not just brightness. If Webb can find planets hiding in bright systems we already know well, imagine what it's finding in systems we've barely looked at yet. Now let's go back, really far back, about 800 million years after the Big Bang. At that point, the universe was still a toddler. Galaxies were supposed to be small, scattered, and just starting to grow. But this year, researchers using Webb spotted something that doesn't fit that picture at all. An active merger of at least 5 galaxies, all colliding and interacting in a tight, dense clump. Far earlier than any model predicted galaxies should be organized enough to do that. This isn't an isolated case either. It fits into a pattern astronomers have started calling the impossible galaxies problem. Since its first year of science operations, Webb has kept finding galaxies in the early universe that are too big, too structured, and too mature for their age, based on our standard model of cosmology. Think of it like finding a fully built, bustling city in a photo that was supposed to show an empty field. Either these galaxies grew unbelievably fast, or there's something in our understanding of the early universe that needs a serious rewrite. Right now, nobody's completely sure which, and that uncertainty is exactly why this is one of the biggest open questions in astronomy today. Let's swing back into our own solar system for a mystery that's bugged scientists for decades. Saturn's rotation rate, basically how fast the planet spins on its axis, has never quite added up. Different measurements over the years gave different answers, and nobody could explain why. Some scientists guessed it was something happening deep in Saturn's interior, maybe tied to its magnetic field or its core. This year, Webb helped put that mystery to rest. It turns out the shifting numbers weren't about Saturn's interior at all. The culprit was something happening in the planet's upper atmosphere, distorting the readings scientists were relying on. Once that was accounted for, the changing rotation rate mystery made sense. It's not the flashiest headline compared to alien atmospheres or ancient galaxies, but it's a great example of what Webb does really well. It doesn't just find brand new mysteries, it also has the precision to finally close the book on old ones. Next, something that didn't come from our solar system at all. Every few years, an object shows up in our solar system that clearly came from outside it, an interstellar visitor. We've only confirmed a handful of these ever. This year, Webb got a close look at the third one ever identified, an interstellar comet, and studied its chemical makeup. What they found was surprising. Its composition doesn't look exactly like the comets we're used to seeing in our own solar system. And that raises a genuinely interesting question. Are the conditions that built our solar system common across the galaxy, or are we actually a bit unusual? Every interstellar object we catch is basically a tiny sample of another solar system, delivered to our doorstep for free. Webb being able to analyze its chemistry in detail instead of just tracking its path is a huge upgrade from how these objects used to be studied. And now, the one you've probably heard the most noise about, K2-18b. This is a distant sub-Neptune planet that Webb has been observing for a couple of years now, and it made headlines when scientists detected a molecule called dimethyl sulfide in its atmosphere, a chemical that, on Earth, is only produced by living organisms, mostly marine phytoplankton. Now, before anyone gets ahead of themselves, this detection currently sits at what scientists call 3 sigma confidence. In plain terms, that's interesting and worth taking seriously. But it is not the 5 sigma gold standard scientists require before they'll call something a confirmed discovery. 3 sigma results have flipped before. So where does that leave us? K2-18b remains one of the most tantalizing potential biosignature candidates we've ever found, but potential is doing a lot of work in that sentence. More observation time is needed, and Webb is already scheduled to get it. This is exactly the kind of story where patience matters more than hype, but it's also exactly the kind of story that could change everything if it holds up. So, in just the past several months, Webb helped uncover a hidden planet in a system we thought we already knew, found a galaxy collision that shouldn't have been possible this early in cosmic history, solved a decades-old Saturn mystery, sampled the chemistry of a visitor from another star system, and kept the door open on the biggest question there is: are we alone? And this is only 4+ years into a mission designed to run for 2 decades. If you want to keep up with discoveries like these as they happen, hit subscribe, because if the last few months are any indication, Webb is nowhere near done rewriting what we know about the universe. See you in the next one.